Bifröst is a system which bridges software and hardware to create a centralized environment for embedded systems debugging. Bifröst consists of a logic analyzer, the microcontroller shield, and your circuit. Let's work through an example to explore the features of the system. First, we will open up the Bifröst IDE. Here, we are using a potentiometer to turn on an LED once the value has reached a certain threshold. Our first issue is that our LED is not turning on. Bifröst has the ability to infer certain conditions. For instance, because digital write is called to turn the LED on, it knows that the corresponding pin should be set up as an output when currently there is no pin mode. In the Status tab, Bifröst warns us that we do not have the correct pin mode set, and we should change our code accordingly. After making the change and returning to our circuit, we notice that the LED is turning on but is flickering even though the input is not changing. Let's take a look at the behavior of the potentiometer by first recording the electrical signals for 5 seconds. During the capture window, we interact with the circuit by turning the potentiometer. Once the run has been recorded, the user can either select which traces to display, or Bifröst can automatically display traces with activity. The traces of both digital and analog signals can be displayed. Bifröst lets us zoom in and visually explore our digital and analog signals. It is also possible to see the internal representation of variables. By double-clicking a variable in the code editor and re-recording, a new trace appears showing the value of the variable as well as an upper and lower bound. Now we have internal system state displayed in the same trace view as our electrical signals. Bifröst can also tie specific trace events to their respective lines in code. When you click a trace event, the interface centers on that point and the line of code is highlighted. The interaction is bidirectional. We can also click in the gutter next to a line of code to bring us to the next point in the trace when it was executed. If we try to do this on a line that was never executed, the software will tell you. Print statements are a standard debugging tool. Bifröst has a serial monitor which adds additional functionality to each serial print by linking them to specific points in time. If I want to see when a counter has reached 12, I can click the respective print statement. We are brought to the corresponding point in the trace view, the code editor, and the progress bar. If we want to see what happens next, we can step through the execution statement by statement, forwards or backwards in time.